You guys can see my screen, right?
Yes.
Yes.
Okay. So now let's start by designing a circuit. Let me just add a voltage source. Oh, that's a standard diode. Let me place one here, and let me put a resistor here, and put some grounds too. A ground here, and a ground here. And now in the experiments we have to use diodes, right? So let me show you how we can add one. Like here, there is a symbol besides the component icon. There's a symbol called the diode. You can click here, and the diode option will come. And you can click on Control plus R to rotate it, or you can use this icon here. Like either should work. So let me just place it here, and after that, let me just use this wire to connect all these. You guys are following me, right? Like, have you opened LTSpice and all? Like,
Yeah.
Yeah. Just ഒരു
this.
minute, 1 minute, so that we can
Yeah,
catch up.
yeah.
Okay, I'm done. Anyone else? When? Hello.
Hello, Dan. Let's start, right?
Hello.
Uh,
Yeah. I
uh,
think we can start. Everybody's ready.
yeah,
Yeah, we are ready.
Yeah. Okay. Let's
yeah.
start.
So let me just imagine a scenario where I want to add a voltage source, a sine voltage source to the circuit. And for that, let me just hover over this voltage source. And when it changes to this hand symbol, let me just right click on that, and a pop-up like this comes up. And here, to change it to a sine source, like an alternating current source, you can click on this advanced option. And here, out of these options here, you can click on this sine, and here you can set the DC offset value to 0, amplitude to like 10 we can set, frequency like your wish. Let me just set it to 1 kilo ohm, and time delay can be 0. The rest is not required for us. And let me click OK. And a voltage source is set right now. Like here it is written like 0 offset value, 10 is the peak value, 1k is the frequency, and 0 is the time delay. And for the resistance, let me just set a value like how much. This is the naming. I just clicked on this R1 here. Like that's why this thing came up. Like here you can rename it. But if you want to change the value of the resistance, hover over it till it changes to this hand symbol, and then right click. Then you can enter the value of the resistance. Like let me just put it as 10 kilo ohm, and let me just click OK. And now comes the interesting part. Like in the experiments, we are asked to select a diode that's not given in the list. When we try to select a, like pick a diode, we can't see the 1N4007 diode in the list here, and that's when we have to import it. Like Alias in the group shared a text file. I will share it in the group again. like you can open that text file. Let me just share my entire screen. 1 second. My screen is visible, right?
Yeah, it's visible.
Yeah, it is. Yes.
Yeah. Yeah, this will be a text file. You can download it, like it's put in WhatsApp. You can download it in the from the WhatsApp group, and you can open it with Word part. And when you open, you can see a text, this thing right here. Like the first part is the source, like where we got this, all those things. Like that's for copyright and all. Like don't mind that. Copy this model up to this whole thing. You have to Control C for copy, and what you have to do is you have to go to LTSpace, and here this icon.
When can you
Spice
wait for a few seconds?
Yeah.
Like again, pop up. Yeah.
Yeah. Yeah.
Okay, Ben, I have downloaded the text file. Then what to do?
You have to open it with any text editor like
Okay.
WordPad or
Okay,
Notepad
Notepad.
or anything like that.
Notepad, yeah.
Okay.
I did that.
Then you can see a text in it, right? Like it
yeah,
looks
text,
like
yeah.
like this. It looks like this. And here
Yeah.
you can copy this part, the part that begins with this dot model.
Dot model. Okay,
Yeah.
okay.
Yeah.
Copied it.
Just copy it, and we don't have any doubts till right now, right? Any doubts?
Ben, text file, can you put it in the chat?
Yeah. One thing. Oh, 1 second. I don't know if you can put files in the chat. Like I will share it. I will share it in the
then
WhatsApp
leave it.
group.
It's fine. Yeah, share it later.
Yeah, I will share it. I will share it later. 1 second. Let me just put it in the Telegram group. 1 second.
Ben, you can mark that the file that Elias had posted in the group again. Like I will do that now. Wait. It's again posted in the WhatsApp group, the bulletin group. Can you please check?
Vaishak, I have posted it in the group. Just check. Dan just referenced it in the WhatsApp group. Like you can select it from there.
Yeah, I did that.
Just open it with just open it with any
Word doc, like a text file.
Any Word
text
document.
File open.
My screen is visible, right?
Yeah, it's visible. Yeah, it's visible.
Yeah. After you have opened the text file and copied the section here, like that begins with the, let me just add a space here. Like here, this model, it begins with this dot model. Just copy that section. And what you have to do then is you have to click on the Spice directive option. Besides this capital A and all, there is a icon called .op and its name is Spice directive. You can just click on there and a pop-up comes up. And in this text box, you just have to paste it. Paste what you have copied from the notepad, from the text file, and just paste the same thing here.
Yeah, I did that. Yeah.
Okay. And when we click OK, the text file will come like this. You can just paste it anywhere. Let me just paste it here. Like you have to click on this Spice directive And when this pop-up comes, you have to paste the thing here. And when you click OK, you will get an option. Your mouse pointer will change to this text, and you can place it anywhere on the screen where you want. Now after that, like after you have pasted this, any doubts till now? Like, can I move on?
No.
Oh, okay. Like after that, to change this diode to this 107, like you just have to, one thing you can do is you can copy this name DI1007. DI107001N4007. DI1N4007. Just copy that. That's that part only. And after that, right click on this name D1, not on this D, on this D1. This is the name of the diode. And when you click on that and just rename it to the name of the diode that we want, DI1N447. That's what I have to enter here. And then click on OK.
When can you say that once again?
Yeah. What you have to do is the text we copied, right?
Yeah.
You can right click on it, and we can edit the same text again. Like we have an option to edit it.
Edit it, yeah.
Then from that window, you just have to select the name that starts with DI and ends at 7.
D. 7.
This is the name of the diode. DI underscore 1N007. That's the diode that we are going to use here. Like that's the one that's specified in the experiments. Just select that name and copy it. Right, you can right click and copy, or like Control C you can click. Like anything is okay. And after you copy it, you can click initially here it would be D1. You can right click on it, and in the name section you can rename it to the name that you copied from there, DI1N4007.
Oh, okay.
And after you rename it, like let me just show you one more thing that I left out yesterday. Let me just extend. Imagine here, this is the point where we want to get the output. Like we want to get the output. Okay. A scenario where we want to get the output at a single point. Like in the question, it's asked where find the output at this point. Like what you can do is, while labeling this port type, right? Like if you want the output, you can change this port output to port type to output.
If it's where is that port type? Where is it port type? Like where did you select that box from?
That's the label, right? Like yesterday we This you can select it from this label net.
Then
and in that window it will be automatically allotted to none. You can use none, no problem at all. But if it's an output for, like, it's just an extra thing, you can use it or not use it, no problem at all. Like if I select change it to output and enter a name, like let me just enter V out and click on it, and I will get a label like this, and I can paste it here. And now what I can do is, like, I can just click on here. I don't have to, when I run this, I don't have to put my pen here, right here, and click. I just have to click on this V out, and I will get the voltage at this point.
Okay, that's when we run. Okay, yeah.
That's when we run. Like our circuit is complete right now. Like it's connected to the ground. We gave a voltage source that's sinusoidal in alternating current, and we gave a diode specified like in our experiments, and we gave a resistance. Now let me just run this. Let me just give a stop time of 5 milliseconds. That's because the frequency of our sine wave is 1 kilo ohm. So we can't give 1 second or something like that, because in 1 second there will be 1,000 waves going through, and it will be very hard for us to analyze anything. So let me just give a stop time of 5M, which is 5 milliseconds, and click OK. Okay, this is my previous one. Okay, this is you will get a window like this. And what you can do is, you can just click on this V out here to get the voltage at this point. And when I click on here, I will get a wave like this. And this is the waveform that we will get after the sine wave has passed through the diode. Let me just
So half wave
delete.
rectifier. Yeah. Okay.
Okay. Let me just delete this and check the voltage at this point before the voltage passes through the diode. Like how's the sine wave performing? Let me just check. Okay.
Yeah.
When we click here, it's a normal sine wave. But after the voltage has passed through it, it changes to this blue one.
Okay.
Like, let me just delete this green one, which is the before one. Like it changes to this.
Yeah.
And that's what this diode does to this sine wave. Like after the voltage, this sine wave passes through this diode, we get a wave like this.
When I think I messed up at the part where we named the diode and thing. Can you repeat that again?
This diode naming, right?
Yeah, the diode naming and the diode selection, we imported something, right? Like from there.
Yeah. Yeah, like I want to do the importing, right? Like just open the text file in any notepad or something like that.
The thing yeah.
Just copy that dot model section, like from this dot to the end. Just Control C, copy it, click on this .op, spice directive, this icon here, and this will be selected to spice directive by automatically. Like just paste the thing here and click OK.
Okay.
And after that, you can place it anywhere on the screen, like anywhere you want.
Okay.
I have already placed it here. No problem at all. You can place it here or anywhere like that. Then what you have to do is you can right click on this text and you will get an option to edit the same text. Okay.
Okay.
And from there, you just have to select the name. Actually, the name begins after the model. After the model, the name begins from here and ends at 7. Like the name of this diode is DI_1N4007.
Okay.
And you can right click on this and select this part DI_1N4007 and copy it. And after that, you can rename the diode. Like you have to rename the diode, not like if you let me just stop the running. If you click on the diode when the hand symbol hovers, you will get a dialog box like this.
Yeah.
Okay. Yeah. You don't have to do that. You just have to like when you click on the resistor, you can change the value. You can when you click on this R1, this is the name of the resistor. V1 is the name of the voltage source. Like if you click on that, right click on that name, you can change the name, right? Like similarly, in the case of diode, you can just click on the name. Here it would be D1. Initially it would be D1. You can right click on that D1 and in that dialog box, you can just paste the name of the diode, which is DI_1N4007.
Okay, yeah.
And then click OK. And the diode name will change to this.
Okay. So this will work, right? Okay.
And that's enough. Like actually, how this works is like when the running is happening, like it will check whether a diode like this is available, and we have already provided the necessary details here.
Okay. Yeah.
So the simulator will know like DI1N4007 refers to this diode which has this properties.
Yes. Okay. Good.
And that's the thing. That's how it works.
Bro, one more thing. When like this one alias and the text file, right? So is there any source for this, like where we can get everything for the future experiments, or will someone from the faculty keep sending us these? How is it gonna work?
The faculty has to send us this. Like actually in this component section, we don't have any AND or NOR gate or anything like that. Like what the faculty does is they will provide a module like digital electronics which has all this. They have to provide. Until now they haven't provided. I don't know why. Like now we don't have any like anything like this. Like and like just an AND FD flop. Complicated things only we have. We don't have simple things. I think Dan should ask. I think like
Dan,
I guess.
Yes, I will.
Yeah. Yeah, they should provide like this. I think alias obtained from the net. It's easily available in the net. You can just search for 1N4077. Like I will just show you that. 1 second. Let's just Google spice model.
Ben,
Yeah,
Ben, my doubt is, do we need to repeat the same procedure if we use this diode in future, or is it automatically uploaded in this LTSpice?
How can we permanently like put it there, like the
Yeah,
diode?
like it's not inbuilt. Like for that you have to use
Import
another import procedure.
procedure.
Like you have to go into the
Yeah.
directory where LTSpice is installed. Like that's different
Uh,
on different computers. Like you can specify
oh,
it during install, and you have to add this diode library to that directory. Like that
oh.
folder. Directory means that folder, or where the like I will just show you that here on my computer, like in my C drive, it's in the program files LTC, LTSpice, and in this
Lib.
lib,
Lib.
this is the this contains all the libraries. These are all the already pre-installed libraries that come with LTSpice. Like
Oh,
the
okay.
faculty will provide us a lib file like this, and then we can add this int folder, and this CMP folder contains all the components. Like
CMP for.
let
Okay.
me just expand this. LTSpace capacitor, LTSpace diode, like all the diodes that we see, right? Pick when we pick a new diode. That's all contained in this standard. Let me just
Standard thing.
with not as also like you can see right. All these models are here. Like it's the same thing that we saw that we added. Like you can just add it here.
Oh, okay.
Dot model, the thing that we copied, right?
We can
This
just
one.
paste it there. Oh, okay.
We can paste it there. I will show you right
Okay.
now. Like the problem is that the problem why I didn't show is the library, the directory would be different for every single person, I guess. Like if you don't go with the default settings, it would be different for different persons.
Okay.
Like that's why I didn't specify it now, because we only need one diode for all the questions.
Yes.
And I thought after the faculty, if after the faculty releases the library file or anything like share the library file, then I will show how to import the whole thing.
Okay.
Like I think that would be more comfortable. Like you can actually what you can do is you can just copy this dot model, Control C, and paste it here.
Okay. My directory file is in C itself, so maybe I can do that.
Yeah.
I set it to default. Okay. Let's continue, I guess. Yeah. That's
okay.
That can be done.
Yeah. And that's the thing. And just click on run. And you can click on this V out and get the
Excuse
output
me,
waveform.
Ben.
Yeah.
Ashin, do you need to try that out now? Like pasting the diode right now? Ashin?
like for permanent.
Yeah. Do you need any like you need any time to do that now, so that if you have any doubts you can ask Ben.
Okay.
Just if you want. Yeah. Just if you want.
Yeah.
Ben, I think we can wait for a few minutes, like 1 to 2 minutes.
Yeah, no problem.
Can you just show that procedure again, where you picked that from?
Like in my case, it's installed in the C drive program files and LTC. There's a folder called LTC for me. And inside that LTSpice folder will be there. And inside that there will be a folder called lib, library. And inside that there will be a CMP folder. And in that CMP folder, you have to look the type. And it will be something like LTSpice capacitor. Sorry, LTSpice diode will be there. LTSpice diode, and you can write.
Paste it there, right? Okay.
click and open it with a WordPad or anything, WordPad or Notepad, anything that contains all the models come. And
On the
here you
standard,
can,
Ben, on the standard of the
yeah,
diode thing, we just need to copy and paste, right? After
yeah.
open.
Just open it with a Notepad and paste it, like just above this.
Okay.
Uh, you can see my screen, right?
Yes,
Yeah,
yes,
yeah,
we can.
yeah.
Yeah. Here, just paste what we just copied there. Like, I think I will just change this to small letters. Model. And just take care to put it all on the same line. Like, just how they have did this. Like, same like that.
Okay.
This capital D is really important. This capital D is what makes the LTSpice recognize it as a diode.
Diode. Okay.
Like,
You have to save it, right?
yeah, we have to save it.
Ben, can you repeat that? I lost connection in between.
They are asking for like permission, like standard.dio was denied. Permission to access it was denied.
Access it was denied because you
So,
are doing this in the C folder. You have to have
so I
administrative
need to change
permission.
my settings.
Like
Okay,
that depends on the PC.
that I will do later. Let's skip that for now. Yeah.
Okay. And after that, if you have done this and saved this, still it won't work. You just have to close your draft and restart LTSpice
Okay.
for the changes to take effect.
Okay. Yeah.
Like if I check my pick a new diode, I still can't see it because I haven't restarted my LTSpice.
Okay.
Like that's a difficult procedure. That's why I didn't want to explain it today.
Okay. Yeah. Okay. It's okay.
Ashwin, you got a brief thing, right? I will send you a link like which explain this in more detail, like after this lecture.
Okay.
Yeah.
Prashant.
Like this is the thing. Like here, like this, you can import any diode that you want, and you can measure the output at any point. Like you can label like this. If you want to get an output, you can label like this, and you can insert a sine wave like this, and that's it. And that's the thing. And I think this much would be enough for the first experiment. Any doubts?
Yeah, clear.
Just before the voltage enters the diode, the voltage will be like this, a normal sine wave. And after the voltage enters, it will change to this. It will be clipped. Like this is called a clipper circuit.
Yeah. Clipper circuit. Okay.
Because it actually clips the sine wave. Like the actually what happens is this diodes will be forward biased. Like in the positive part of the sine wave, this diode will be forward biased. So the diode will pass the sine wave that diode will be reverse biased. So diode won't conduct a current. So there will be no output. And after that, the positive cycle comes and the diode becomes forward biased, and so it conducts. And after that, the cycle repeats. For the negative sections, the diodes is for reverse bias, and for the forward things, it is reverse bias. That's the thing.
Yeah.
Can you repeat that once more?
Yeah. Actually, what happens is a sine wave is going through the diode, right? And in the positive cycle of the sine wave, the diode becomes forward biased. This diode, it becomes forward biased. So it conducts the sine wave that comes across it. And in the negative cycle of the sine wave, the diode is reverse biased. So it
Because
won't conduct any
the polarity reverses. The sine
Polarity
wave
reverses.
the polarity reverses.
Understood.
Yeah.
Alternating current, right? So polarity reverses, so the diode becomes reverse biased, and so it doesn't conduct it. It acts an insulator, and in the next positive cycle, it is forward biased, and so on. That's the theory behind this. Understood, right? Any doubts?
Yeah, it's clear. When
Yeah, it's clear.
when do we have anything to add, like the BJT and
for the
MOSFETs or something?
BJT and MOSFETs is really complicated
Complicated,
topic.
okay,
I
okay.
don't want to I don't want to complicate it right now.
Oh, okay, yeah.
It's not
Sure,
necessary for the first experiment. That's the thing.
Oh, okay, okay, okay.
And we haven't been taught BJT and MOSFET, right?
Ah, yeah, we
so-
haven't been, yeah.
So
Ma'am told she'll take it in class, and then only we need to